Greg, I know we were just talking about what happens inside the robot. We got to be able to make assured positive connections. What are some of the types of solutions that you guys offer in terms of making connectors for power and signal?
Absolutely. So our solutions need to be adaptable. They need to be able to be polarized. So as Matt said, they're not being able to be mismated. A lot of the robust features like the hold downs are important so that the reliability is taken into consideration. And then the different architectures allow different form factors, different size connections, and really be able to be robust enough for the application.
So are there some specific things that you're doing that you could show me in terms of maybe making these positive type of assurance connections?
Yeah, so one great example is our microspace solution, which is a cabled solution. And this one in particular is a waterproof and also has the robustness of an active latch, as well as things like CPA and TPA terminology, which for TPA is what we call terminal position assurance and allows anti-backout for the cable. And then for the TPA, it's essentially a secondary latch to ensure that it can't be unmated accidentally.
Okay, and that's that red latch there?
Absolutely.
Yeah, so that works as it assures that it can't back out. Tell me a little bit about the wireless communication. What's going on with radio frequencies inside of a factory and a warehouse? What are some of those operating conditions and what's being deployed there that you see?
Well, we're really seeing an evolution of our products. For example, FACRA has been used for quite a while in the automotive space, and as that continues to evolve into what they call the mini FACRA, we're seeing that same thing in the automotive space, and it gives you a higher data rate than you normally would see and reduces latency within there. So as you can imagine, you've got all these robots moving around in unison together. You can't have them running into each other, and there needs to really be a network communicating, and that's being driven by this. So you're going to see that. In addition to that, you see the miniaturization of the solutions themselves as time goes on. So where here you have this single connection, you have basically the same architecture, but you can have four in that same area.
So that's the mini FACRA where I get 4 times as dense.
Correct, yes. And that pitch and that overall gang solution really makes a difference. And certainly for anyone who's building a board, being able to mount a single connector and have 4 connections, anyone who's dealt with coplanarity issues and things of that nature, this really makes life a lot easier.
Yeah, awesome. Hey, Greg, we were just talking about the automotive industry, about how some of that's transitioning into the industrial space. Could you share a little bit about how some of those ideas are underway?
Yeah, so there's a lot of transition from what we know as U.S. car standard, which is mainly geared towards high shock and vibration. And a lot of our solutions, like our Burke stack family of products, allows us to be able to ensure that high reliability shock and vibration. So these solutions are able to transition from automotive into this harsh environment warehouse setting to be able to adapt and really be able to show the true reliability of the system.
Great. Now, Matt was mentioning how they have the mini FACRA, which is a more dense version. My understanding is that Amphenol is making industrial autonomous mobile robot solutions that are even more dense. Could you speak a little bit about what you're doing in that area with small pitches?
Yeah, so the key here, Paul, is to be able to understand the different challenges that you have within the architecture. So in a lot of cases, for the miniaturization, we go all the way down to 0.4 millimeter pitch. And a lot of the considerations for these type of connections is different stack heights, different position counts, different features within, you talk about alignment. In a lot of these cases, we're able to adapt to many of those considerations.
I think another thing that I've heard that you're able to do is custom tailor solutions. Could you speak a little bit about your capabilities there?
Yeah, so one example that I have here is our combo stack product, which is traditionally actually a board-to-board product, but here we are putting it on a rigid flex, which is essentially cableizing it and allowing it to go over an extended length, if you will. So in a lot of cases, we can be very adaptive to the type of architecture within various different types of mobile robots.